is with presidential elections and polling. So have you ever been watching the news and the news reporter says something about a Quinnipiac survey and they say that candidate X is predicted to receive 53% of the vote? You're thinking, great, okay, candidate X is going to win. They're going to get 53% of the vote. But then there's this little fine print at the bottom that says plus or minus 4%. Well, that plus or minus 4% is what we call the margin of error. They're just taking a small sample of people. They're not going out and interviewing the entire voting population. That's when the election takes place. So they're just surveying a small amount of people, and they're saying, okay, so out of the small amount of people that we surveyed, this is how many percent said that they would vote for this candidate. So based on how many people they surveyed, there is kind of a window. There's some error in there. And so what the margin of error means is it means they are 95% confident that candidate X will receive between 49% and 57% of the vote. Now, sometimes that confidence level can vary. You can have different confidence levels, but we're just going to focus on the 95% confidence interval. So that plus or minus 4%, that's where the 49 comes from. 53 minus 4% gives you 49%. So that's the low end of the actual percentage. 53 plus 4% is what gives you the 57. That's the high end of the percent of the vote that candidate X is predicted to receive. Okay, so that's how the margin of error works. So let's look at another situation here with an election. Senators Smith and Miller are in a close election. Senator Smith is projected to win 52% of the vote with a 5% margin of error. So what's the highest amount of the vote that Smith is projected to get? Well, he is projected to win 52%, but there's a 5% margin of error. So you add the 5 for the highest amount, you add the 5%. So the highest amount he could win is potentially 57%, according to the survey. Now, we all know that actual results turn out differently in the end, but this is the statistics prediction, okay? The smallest amount, you subtract the 5%, you subtract the margin of error from the projected amount, and you get 47%. So there's a 10% range here of what he could actually get of the vote. Let's look at the third question. What is the highest amount of the vote that Miller is projected to get? We weren't given any numbers for Miller, but let's just assume we weren't told otherwise, so let's assume this is a two-candidate race. So together, the two candidates should receive what percent of the vote? 100%, right? Together, they're going to get all the vote. So for Miller to get the highest amount, Smith has got to get his smallest amount. So if we take 100% minus the 47%, the highest amount that Miller is projected to get is 53%. So there's still the possibility that Miller could win this election. If Smith gets his smallest percent, then Miller could indeed win the percent or win the vote. Okay, kind of flips around there. Any questions? Okay, let's look if we're given some different information. Example 2, the percentage of people who speed through town is between 35% and 43%. So we're not given a percent number and a margin of error. We're given the range here. Okay, so we know the low, we know the high. We want to find what is the mean percentage. What is mean in math? What is mean another word for? Average. Mean is another word for average. Excuse me. So if we were averaging two numbers, what do? We add them together and divide by 2. So 35 plus 43 divided by 2 is 39. So that is the mean percentage right there. You found what was in between that range. Now, what's the margin of error? Well, now we know the number in the middle, So if we subtract the lowest number, we get 4%, or if we do the highest number minus our average, we get 4%. 4% is the margin of error. We were just going backwards from the first example we were doing. The first example, we were given this information. We were given the mean percentage and the margin of error, and we came up with the range. Here, we're given the range. We're coming up with the mean percentage and the margin of error. Now, technically, you don't have to do both these calculations, the 39 minus the 35 and the 43 minus the 39. I was just showing you that both of them should give you the same number, right? If you add it or if you subtract it from the mean, it gives you the range. All right, so in those examples, we were given the margin of error, or it was very easy to find the margin of error. Let's look at, well, what if we have to calculate the margin of error? This is one formula for the margin of error. There are several different formulas out there. This is the one that we are going to use. Now, if you are on the EOC and they give you a formula for margin of error, sometimes they give you formulas in the problems, use the formula that they give you, okay? Use the formula that they give you, but if they don't give you one, this is the one that we're using. Plus or minus 1 over the square root of n. Now, the plus or minus is just there because we add the margin of error or we subtract the margin of error. Okay, that's what that is. N is the number of people in your sample. So let's look at an example. In a poll of 150 students, 78% said that they liked their teachers this year. Find the margin of error. So in the problem that they gave us, 150 is our N. 78% is the mean percent. So if we're finding the margin of error, I'm just going to abbreviate that MOE, that is plus or minus 1 over the square root of the number of, in this case, students that were surveyed. Okay, we're going to put that in our calculator. You don't put the plus or minus in. Okay? You just put in the 1 over the square root of 150. And we need to convert that to a percent. Okay, that is the margin of error in decimal form, but we need to convert it to a percent. So we move our decimal 2 places to the right. So 8.16% is our margin of error. Part B says write the certainty statement. So the certainty statement, it always starts the same way. We are 95% certain that between, we need to do 78 minus 8.16, and we need to do 78 plus 8.16. So that should be 69.84% and 86.16% of students liked their teachers this year. Okay, that is the certainty statement. The beginning of it always starts the same. We are 95% certain. That does not change. That's our given. We are 95% certain that between, we take our percent, subtract the margin of error, our percent plus the margin of error, that's where those numbers came from, and then whatever the survey question is about. In this case, students liking their teachers this school year. Any questions about that? Pretty straightforward. All right, let's look at that last question there. How could we make the margin of error smaller? How can we make the margin of error smaller? So the margin of error is 1 over the square root of our sample size. So anybody have a hypothesis there? What could we do to make the margin of error smaller? Obviously, it has to do with the sample size. So we got two options. We either make our sample size bigger or we make our sample size smaller. What do you think makes sense? Okay, I heard one of each. Let's test it. Okay, what if we make it smaller? Let's say we only survey 50 people. If we make it bigger, let's say we survey 500 people. 1 over the square root of 50. That gives us 14.14%. 1 over the square root of 500 gives us 4.47%. Okay, so which one made the margin of error smaller? Making the sample size bigger. Now, this is not something that you need to memorize, but let's think about this for a second. Okay, let's think about this for a second. If we're talking about surveying people and wanting to present results, would it make more sense that our results are better or they're more valid if we survey more people or less people? I mean, if I want to ask, if I want to see how many of my students thought that I did a good job of teaching this semester, if I just ask 2 of my students, do you think that that's going to give a very good result versus asking 50 of my students? Right? It's going to be better to ask 50 of my students because I'm getting a better representation of all of my students. So that's going to reduce my margin of error. I have more results, so I have better results. So it's better to have the biggest, not necessarily the biggest sample size you can, but bigger is better for sample size. Okay? All right. Let's look at flipping this around. What sample size is needed to produce a margin of error of 7.5%? So this is a typical statistics question. People say, okay, well, I want my results to be this precise, so how many people do I need to go out and ask this question of? Okay, so it's reversing the order. We know the answer. I'll go to lunch.